Everyone, May 14th. All right, solve this one first. And then we have to try the other method for this one. Swapping nodes. You're given a head, an integer k. Return the head of the linked list after swapping the values of the kth node from the beginning and a kth node from the end. I mean, depending on what you mean by swapping the nodes. Okay, so we can do it cheating way, right? But we're not. We're doing the real way, which is swapping the nodes. So the question is, how do we count kth? We can always count kth from the front start, right? I think so. We want to end up at this place. This is one index, okay? How do we end in this place? Well, so this to this has k, right? So if I have something is already at k's position and I go all the way down, then we'll have this position, right? Yeah, so what I'm thinking is something like this. So we have, let's say we have these 5. Okay, we always have a dummy at the front. So a dummy at front, and we put a front here, and back, let's say k equals 2. So the 2th, which means we have 1, 2, 1, and so that's how about k equals 3? So k equals 3 will be here, right? Then I move all the way down, right? So this one will go 1, 2, 3. So move to here. This one will go 1, 2, 3. Move into here. So now this is the place of the node in front of the target node. Is that right? Because I have 1, 2, 3. That's actually not right. Because 1, 2, hold up, 1, 2, 3. I want to get the node in front. Oh, wait, hold up. That's 1, 2, 3 should be, hold on. Let's redo this. Let's redo this. That ain't right. This is the start. This is the start. This is 1, 2, 3, 4, and 5, right? So if a k equals 3, so I'm actually looking at this one, right? And then we move down 1, 2, so move down here. This one go 1, 2, so we move down here. So this is the node in front of the node that we want to swap. Okay, so this node we have, and then we need to get the third one, which is to go from here. We'll still go from here. We go 1, 1, 2, 3. So oh my god, it's the same node. It's the same node, but it doesn't matter, right? So we basically say we want this node to swap with that node. Oh, what would happen if it's the same node? Well, basically we'll say get this node out, get this node out, and then we'll cut on one and then put in another one. Yeah, I think it will work. I think it will work. Not 100% sure, but take a look. So we will have a I'll have a dummy, right? List node next equals head. Okay, so we will have a left and right, low and high. Okay, so low will equal to dummy, and while k minus 1, right? Because we only do k minus 1 times. Well, we can say for this in range k minus 1. Low high will start the same, and high equals high dot next. right? So this we move k minus 1 times. Then we move to that, and then we say while high equals high dot next, low equals low dot next. I probably shouldn't call it low. We shall call it second. Let's call it second. Second. Okay. Second. Okay, now first equal to dummy. Then for this range, oh, I already did it. And we should say first equals high. Then high keep going. All right, so now I just need to swap the two nodes. How do we swap? Well, we will say first dot next shall equal to second dot next. Okay, first dot next equals second dot next. Oof. Then we are losing, right? We're losing. We need a temp. Let me get a temp. Temp equals, then we're gonna do swap. Temp equals to first dot next. Okay. Then first dot next equals second dot next. Okay, and then we say second dot next shall equal to temp dot next. Okay. And that done. First one done. Now we need to move temp to the right side. Then we say second dot next equals temp. And temp dot next equals, ooh. Hold on. First dot next equals second dot next. That's fine, right? And then, okay. And then second dot next equals temp dot next. Then we're losing it. Dude, oh, is there a systematic way to do this? First, first dot next equals second dot, that's fine, okay? And then we have a temp, okay? And then second dot next, we need another temp. We need another temp. Oh my god, this is, can we make it, okay, can we make it easier? First, second, oh my god. Let's do this. Let's make it easier. So we have swap left, right? Swap left and swap left next equals first dot next and first dot next dot next. Swap right next equals second dot next dot next. Why did you call it second and first? I think we should change the name. These are not second, they're called swap right pre. Okay, and the first shall be called swap left pre. Okay, now we have all these. Now we can do the swap. So we can say swap left pre dot next shall equal to swap right. Right? Shall equal to swap right. And then swap right dot next shall equal to swap left next. Okay? And then we say swap right pre dot next shall equal to swap left. And swap left dot next shall equal to swap right next, like that, and we'll return dummy dot next. All right, let's see. Let's see how this one goes. This one right? There's a none. What the hell? This is probably the second one, not the first one. Hold on. First one passed. Hopefully the first one passed. No, the first one doesn't pass either. Okay, we have a serious problem. All right, dummy is the front. And the swap right pre equals high equals dummy. Okay, and then we go k will equal to k minus 1 is 1. So high equals high on next. So high will be here. And then swap left pre. That is correct. Right, swap left pre is right. And then while high is, yeah, swap left pre here. High is also here. And then high equals high on next. Okay. And then swap right pre to here. High equals high on next. So here, high equals high on next. And the other one is going to be, that doesn't sound right, right? Hold up. We got 1, 2, 3, 4, 5. Okay. Dummy is here. So I say the pre, right? And then high, both are here. And high move on to 1. And then we say this is a right pre. So left pre is here. That's correct. And I want to go all the way down to here. But then the right pre will be here. That's not right. Right pre shall be here. Huh. Oh, that was not right. Left pre is right. We should actually move it down more. Right? The high actually should be here. Because I want the high to be reaching this one. And then the right pre to be reaching this one. Yes, they shall be one more in between. And when that happens, okay, so this is not right. Should be one more in between. Which means that actually we have to do k times 2 will be 1, 2. So they are kind of spread out. So one is here, it's going to be here. And it should be while high down next. And this is not right. Okay, so, and then we need to do swap left. So it's a swap left pre shall equal to dummy. And for this in range, now it's k minus 1. Swap left pre equals swap left pre dot next. Okay, so with this change, let's see. What do we got? Is this one right? Okay. I have a more evil test case. Found psych. Oof. Damn it. Damn it. All right. Oh, yeah, this is because this is too much. Jesus. All right. Let's try this one. So what do we have? 7, 9, 6, 6, 7, 8, 3, 0, 9, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So swap these two. What are you doing? So I have a dummy, right? So I say, I go k times, so 5 times, right? So from here, 1, 2, 3, 4, 5. So the high is gonna be here, and then we'll go 1, 2, 3, 4, 5. So this one goes 1, 2, 3, 4, 5. Hey, it's not right. Oh no, it is right. Oh shoot. So the pre is here, right? So the right pre is here. Damn it. Left pre. 1, 2, 3. Left pre will go k minus 1 4 times. 1, 1, 2, 3, 4. So this is the left pre. Okay. Oof. I say this left pre dot next equals, so I move this one pointing here. And then I say right dot next pointing to swap right. No. Right dot next swap left next. Swap left. This is a swap left, right? It's a swap left, and then it's also right pre. So swap left, and a swap left next. That's a swap left next. Damn it. And then the right pre, and this is a swap right. This is a swap right next. Dude. Yeah, we was pointing here, and this shall pointing to swap left next, which is pointing to itself. Oof. All right. So that is a little bit troubling. Now, how can we solve this? How do you swap these? I mean, what are the situations, right? If this is the left, we at least have 2, right? And this is the right. Then yeah, this has to be pointing to this pointing to this, and then that's right. Actually, if there's only 1 in the center, that will also work, because the pre and they're just the same, right? Which means this swap left pre dot next, so this will be pointing here, and swap right is swap left next, so this will be pointing here, and then swap right pre dot next, so this will be pointing here, and this will be pointing, yeah, that will be right. So the only time it's not going to be right is if the swap left and the swap right are right next to each other. So that is a special case. So when that happens, we just swap these two, which means swap. If swap left, wait, hold on, I need to get these one first, right? And let me just say, if swap left dot next, then what if the k is huge? Equal to swap right, or swap right dot next is equal to swap left. That is to counter for the situation where k is big. If k is big, then the swap left is on the right side, swap right is going to be along the left side, right? So that's to prevent that from happening. So if this is if the swaps are adjacent. Okay. When that happens, all we need to do is just swap these two. Now, how do we swap these two? So we just do swap left tree dot next equals to swap right. Okay, and then swap right dot next equals swap left, and then swap left dot next equals to swap right next. Else they have at least one in between. Okay, let's try this. All right. Do we have another special case? For example, I have only one. Okay, k can be 1. That's a good case. Of course, that's a good idea. I say 1, 2, 3, 4, 5, 6, 7, 8. Oh, and we can do 6. These shall cover everything. Yep. The last one. I found an error. Oh. That is correct. Because you need to, because this is the left is on the left hand side. If it's on the other one, so I probably have to do it this way. Aleph Alright, then we need to do exactly the same thing, but this should be right, left, right, left, left, right. Yeah, I'll try this. Okay. It took a while. I feel this is probably not the best way. If swap left is on the right to swap left, swap right. Right. I don't like it. I don't like it. This feels wrong, right? Feels wrong. Two sets of edge cases. First, when swap left and swap right are adjacent, we must swap them directly without resorting to another node in between. Second, when k is big and swap right ends up, swap left ends up to the right of swap right, and if they are adjacent, the swap is the opposite compared to when swap left is to the left of swap right. All right, let's see what I do in the past. I don't know why it looks faster today. This is, oh my goodness. All right, I have to take a look at this one. Oh, you just, dude, don't do this. I'm swapping the value. Is this swapping the value? Oh my god. You're swapping the value. You're swapping the value. You're literally swapping the value. No wonder I never remember this to be so difficult, because I've always been swapping the value. But today we're not swapping the value, we're swapping the actual nodes. It says swapping nodes. If you swap the value, then we're already done, because we find the nodes already. So this is good, right? This is good. I'm not swapping values. I consider this one done. I want to do this one, but using yesterday we saw the method, right? We have a method 2. I'm gonna try it, which is use bit mask to represent the state of the numbers that have been used. This way we can memorize, right, the results of a state that have been solved previously. Now we basically go through all possible combinations to find the best, to find the largest value, largest score. All right, so we will have a, does that still count as backtracking? No, this is actually a, we'll have a state, right? So this is actually just a DP. We have a state. State actually is an int, and I'll return an int, right? Doesn't matter what we do, and eventually we shall return DP 0, right? Nobody gets done. And then given the current state, we'll pick 2, right? And then we go for the result. And we should say rest equal to 0, right? And then we should say for I in range, let's get n equals len nums. Right, so for I in range n, for j in range I plus 1 to n, and we say if these two are not taken, then we'll take it, right? Oh, we need operations as well. All right, we need operations as well, OP. All right, then we say if both are not taken, so that's state and 1 left shift I, right? See if it's taken, and left shift I, so shall be this need to equal to 0. And state and 1 left shift j, right, shall equal to 0, which we can do. We can say this or this, right? We can say this or this. So this has to equal to 0, right? If this is equal to 0, then we can take it. We can take it. So we say res shall be equal to maximum. Res, what is my current? So the current gonna be math op times math.gcd nums I and nums j, right? this plus dp the state. Let's say we did to take shall equal to this. Okay, this is to take. So if this to take is equal to 0, then dp state will be state or to take, and op will be +1. Right, maximum equal to this. If not, then yeah, we cannot take it. Then we try another one, try another one, try another one. So always try 2, right? So once we finish 2, we go to the next one. And then blah, 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 we'll return res. And this we need to functool it. Okay, so we do let's see, so it works. OP operation, one base, right? Operation is one based. It works, but looks slow. Maybe we'll pass. Maybe we'll still pass. Take a shot. Yeah, that's, I think, is the normal solution. And my solution was fast. A little bit, you know, a little bit greedy kind of thing. But this is the regular solution. What's the runtime on this? Well, with the unique states and operation, right? So it's operation multiplied by the state. And we have to multiply it squared. So the state is 2 to the 2 to 2 to the 2n and 2n squared, and log a is this, right? Log a is this. Yes, I agree. That's the. So O, why would you say 2 to the 2n? What's n? 2n. We just say O 2 to the n times n squared times log, I call it log a, that's fine, where n is length nums, or 2n, right? That does make things much easier. I mean, this one took a while. Okay, so we consider this one solved as well. Let's move on. Let's hit one more before we call it a day today. All right, what's this one? Maximize greatness of an array. You're given a zero-indexed integer array, nums. You're allowed to permute nums into a new array of your choosing. We define the greatness of nums to be a number of indices for which permutation I is larger than nums I. Return the maximum possible greatness you can achieve after permuting nums. So you want to permute it, right? And after you permute it, the permuted version at each position need to be larger than your previous. And if it is, then you have greatness. We define the greatness of nums to be the number of indices. Okay, the number of indices you can achieve. So if that's the case, one of the optimal rearrangement is 2513311. Huh. It's an interesting question. Like it. I like it. 1 3 5 2 1 3 1. So I want to permute it, right? Such that we have positions that we can give maximum. Why don't we just sort it? 1, 1, 1, 2, 3, 3, 5, right? So the max we can get, so we have, yeah, at most, so we want to say, okay, we want to find something, so we want 2 coming here, right? Okay, 2 pair with this, well, 3 pair with this, 3 pair with this, so it will be 2, 3, 3, and then 5, 1, 1, 1. And then we have 4, right? Yeah, because it doesn't really matter. We can just sort it, and then we just find how can we align. Yeah, we can just say equal boom. So I can say, okay, this can move here, right? This I can move here, and then yeah, once we hit the first one that's larger, right, then we can always cover the front, and the next one we can always cover this one. The next one, if it's equal, that's the thing. If it's equal, if it's larger, then we always can cover, right? So if it's equal, we need a previous. Hold on. So what do we say? We have 2 pointers. One is here. The other move. Okay. Move. Boom. Larger. When it's larger, we record, and then both move forward. Okay. So it's just the right, high, low. Okay, and then we both move forward. So low, now low is here, high is here, still good, move forward. Low is here, high is here, still good, move forward. Low is here, high is here, still good. That's 4. Yeah, 1, 2, 3, 4. Low and a high, boom, 1, 2, 3. Yep, that's the solution. It's like permutation, right? Permutation means you don't, dude. Oh, that's not 16. It's this. Okay, nums.sort. Low, high is going to be 0. And then we need to move high. Okay. Actually, high, we can just set low. High can be like this for high in range len nums. And the rest. If nums high is larger than nums low, right? Rest plus equal 1 and low plus equal 1. Then we'll return rest. Okay, let's try. And let's try. Yep. I think that's the solution. Sort the nums and 2 pointer. Each time the high points to a value larger than low, that is a valid right? That is a valid. That is a greatness. That is greatness. Okay, let's see. That's the solution, right? Sorting and two pointer. Yeah, that's basically what it is. Sort. If this, yep. What do you think? Nah, I don't want to do it anymore. So let's just call it.